Welcome to my favorite day of Chapter 6. We're going to talk more about trigonomic identities and actually prove the following identities. So, to me, these are just little puzzles. You can solve it one way or another way, and it will not matter. It kind of is what jumps out at you first. Run with it. If you get stuck, then go back and try a different way. But you need to be resilient. This box right here of basic trigonomic identities should be familiar from our previous video. We have 3 key identities that are going to be used, as well as the first one you can break it into 2 new ones where you take, cosine squared theta equals 1 minus sine squared theta. That could be used if needed. Or sine squared theta equaling 1 minus cosine squared theta might be used. So my little tactics. Start with the more complicated side of the equation. These will allow you to just work one side pretty much all the way to the end. So pick the most complicated side and say, hey, I'm going to clean up this side. My second tactic is to express all trig functions in terms of sine and cosine. This will allow for terms to be canceled easier and simplified out with the other side, with that current side of the equation. I know the suspense is killing you. So here we go. We're going to do step 1 and step 2. We'll do a couple examples. I'm going to have you pause the video sometimes to try it on your own, and then we'll move on with day 10. So prove the following identity. Step 1 is choose the more complicated side. Obviously, in this case, the left side is more complicated, so this is where I'm going to start. Step 2 is express all the trig functions in terms of sine and cosine. So I'm going to write cosecant as 1 over sine of A times tangent of A. I'm going to rewrite as sine A over cosine A. And then cosine A can actually just stay as cosine A because it already is in terms of cosine. And I'm going to leave the right side as equal 1. Notice now my goal is to clean this left side up so that it equals 1. Writing it as sine and cosine, notice this sine A will cancel because you're dividing the like term, the like sign. As well as this cosine and this cosine, because they're being divided, cancel out. Only thing left on the left side is 1, and it equals the other side. To say you're done with an identity, you put a nice little check mark. Left side equals right side. And you just proved your first identity. Okay. Let's try some more. They all are very different. So there's not just one best way, but following those 2 tactics really help. Looking at this, you have 1 minus cotangent squared theta divided by cosecant squared theta equals sine squared theta. Looking at it, I believe the left side is more complicated. So I'm going to start on the left side. I'm going to rewrite everything in terms of sine and cosine. So 1 is just going to be 1 minus cotangent squared is the reciprocal of tangent squared, which means it's going to be cosine squared theta over sine squared theta. That's the numerator. Cosecant squared theta is the same as 1 over sine squared theta. And we want to show that it equals sine squared theta. Okay, now we're going to do some algebra rules. Instead of having a fraction in a fraction, you know you can divide by a fraction is the same as multiply by the reciprocal. So maybe you'll just need some algebra steps in your noggin. So I'm going to rewrite this, cosine squared theta, sine squared theta. Instead of dividing by this fraction, I'm going to multiply by the reciprocal. And I'm keeping my goal in mind that I want it to equal sine squared theta. Just like in example 1, these two sine squared thetas can cancel because they're being divided, leaving the left side as 1 minus cosine squared theta. Looking at that left side, if I go back to the very beginning with my identities, hopefully one of those is jumping out at you. 1 minus cosine squared theta, it equals sine squared theta. These can be used moving forward and no explanation is needed, which means I can go right to this problem, substitute 1 minus cosine squared theta for just sine squared theta because it's one of my identities. Left side equals right side. Put that check mark to show that you are done. You just proved your second identity. Example 3. Cosine squared b minus sine squared b equals 1 minus tangent squared b over 1 plus tangent squared b. They both don't look super nice, but it's pretty clear the right side is more complicated. So that is where we are going to begin. First advice is rewrite everything in terms of sine and cosine. The numerator will become 1 minus sine squared b over cosine squared b. The denominator is 1 plus sine squared b over cosine squared b. You may not cancel in this case because of the addition and subtraction. It's a big group. So we have to do a little bit more algebra in order to simplify. Well, looking at it, maybe just looking at the numerator, I want to somehow combine 1 and this term together. When you subtract fractions, you need common denominators. Which means if I multiply this 1 by cosine squared b over cosine squared b, I will be able to get like denominators, like bases. That would look like cosine squared b minus sine squared b over that common denominator of cosine squared b. That's just the numerator, getting that common denominator to subtract those terms. Then looking just at my denominator, make this a little bit bigger. Just at the denominator, I also want to get like terms so I can add those, which means I'm going to multiply by cosine squared b over cosine squared b in the denominator. So I'll end up with cosine squared b plus sine squared b. Again, that's over the common denominator of cosine squared b. Well, I have fractions in terms of fractions. Let's use what we did in number 2, which means, I ran out of room, instead of dividing by a fraction, I can multiply by the reciprocal. Here's my numerator. Instead of dividing by that denominator, I can multiply by the reciprocal. Cosine squared b over cosine squared b plus sine squared b. Seeming like a pattern where these will now cancel because it's in the numerator and denominator. But the cosine squared b minus sine squared b and the cosine squared b plus sine squared b will not cancel. They have different signs. At this point, what I like to do is go back to my problem. I'm trying to have it equal this. It looks like I have that in my problem. The left side could equal the right, except for the fact that I have this extra denominator. Is there any way I can get rid of that? Yes! Go back to your beginning. These identities that you want to have learned, loved in your noggin, right here. Sine squared theta plus cosine squared theta is 1. Doesn't matter the order because it's addition. So this right here, you can just write a little note or maybe circle it and say this is really 1. That's the identity is 1. Leaving you with the right side equaling the left side. When you're done, you put a nice check mark showing that you finished your identity and you just solved your third identity. Throughout the whole problem, you are always allowed to leave that left side that you're not working with. You can kind of carry it down as you go if you would like, as I showed in example 1 and 2. Or you can just work on the right and then just put the left at the end. It won't matter your process. It kind of just guides you to your answer. One last one, and then I'll be a ton of practice in class. There is a new tactic I want to suggest. You always still start with the more complicated side. You always express all trig functions in terms of sine and cosine, but then still there might be some more problems. My third tactic is to rationalize that denominator. Might be a good idea, and I'll explain that as we go. Example 4. We have cosine over 1 minus sine theta equals 1 plus sine theta over cosine. They both kind of seem messy. In this case, you can decide which one you start with. I'm going to choose the left side because the denominator is 2 terms, 1 minus sine theta. Then I can use my third step of rationalizing the denominator. So I'm going to use the left side. I'm going to start at the left side. We have cosine of theta over 1 minus sine theta. When I say rationalize the denominator, we did that with square roots where I don't let you leave square roots in the denominator. Okay, that's called rationalizing the denominator. You're going to do that here as well, but this time it's more saying if you want to get rid of a value in the bottom, sometimes it helps to do this idea, which is multiply the top and the bottom by 1. This one is minus sine, so I'm going to do plus sine theta. I do the opposite of the sign in the denominator. When you multiply on the numerator, you're going to distribute. So it's going to be cosine theta, 1 plus sine theta, and we'll distribute. In the denominator, you will have to FOIL. Some of you probably got a huge smile on your face because you love it. Yeah, it's not going to be bad. Okay, FOIL the denominator, distribute in the numerator. Just some algebra skills. Numerator becomes cosine theta plus cosine theta sine theta. Denominator becomes 1 minus sine theta plus sine theta minus sine squared theta. When you FOIL, these cancel. You're doing great. So here's my numerator. My denominator. And now I want to take a quick step back and be like, what am I trying to have it equal? Looking back at the problem, my goal on the right side, 1 plus sine theta over cosine theta. Sometimes this helps so that we really can see what are we trying to do. Well, the bottom needs to be cosine. Using my identity from the beginning of the video, we can notice that the denominator is going to be cosine squared. Use that just from the chart at the beginning of the video. Somehow though, I want it to just be cosine. And in the numerator, I just want 1 plus sine theta. Oh, notice there's a common cosine that I can factor out. How cool! I can do a nice GCF in the numerator. 1 plus sine theta will be left. In the bottom, this cosine will cancel with one of those cosines. And just like that, you now get the right side equal to the left side. Put a nice check mark, show that you did your identity, and then you're done. One potential way, my dears. For example, if you did not distribute at this step, that's right here. I might have did an extra step that I didn't need. Not wrong. I didn't see it at the beginning. That's why it really helps to set that goal of the left side equaling the right. Don't change both sides. Just change one until you get to the very end. We'll be doing a ton of practice, so if this is not clicking right away, no stress. I got you. Have a great day.